We have had a huge amount of customers pursuing us for the refactor use case, which has turned out to work really well for them. So why is everyone pursuing Blitzy for refactor, and what makes us stand out?
Well, if you think about refactors, these are like massive jobs where you're taking all of the client's code, you're taking all of their configuration, and you're converting it into something more modern. Like, for example, one of the most common refactor examples is you have an old version of Java, you want to containerize the application, so you move to the latest version of Java plus Spring Boot, right? And then you add containerization features. We're doing several POCs like that. Now, for that, you need to be able to fit all of their files in whatever repository they're using, one or multiple repositories, right? And then you need to have context of the design, right? So in a typical human-led refactor job, you would have humans on their end and humans on the agency side or whoever's running the job to coordinate, try to understand the design, talk through the process, and that takes months. And then executing and writing all of the code again takes a lot of months, back and forth on communication, on trying to understand everything, pushing all the changes, not breaking stuff. And then there's a whole onboarding period once you've built all the code to reintegrate and test all of that and get it working. The reason Blitzy is groundbreaking in this space is because we've unlocked the ability to process these large-sized repos. We can do repos ranging from a few thousand lines of code to millions of lines of code, right? And we've done that because we invented technology that allows us to use the context window of LLMs optimally and fit just as much information as they can support, both from an input standpoint and also orchestrate the output such that we always produce the optimal amount of code that is needed to solve that problem. And we can batch build and execute these jobs overnight. So if your repo has, like, let's say, maybe hundreds of thousands of lines of code, you could do that in about 24 hours in a single job with Blitzy. So we get rid of the communication cost, we deploy compute to solve all of the groundwork, and you can have human engineers to complete the last mile of changes that you would need, which, depending on the complexity of the repo, can range from a few hours to a few days.
And so talk to me about where the scale stops, right? We've had requests for 1 million, we got a request for a 20 million line mono repo about 2 hours ago. So, where does the limit of effective context window end, or does it?
Well, if you think about today's models, the longest context window model that I have seen from an input standpoint is about 1 million with Gemini. The largest context window output I've seen is about 100K tokens with OpenAI. These are two different models, right? But with OpenAI, the catch is that that model is O1, by the way, and the catch is that it includes reasoning tokens, so you don't really know how much output it supports.
Right.
But Claude supports about 8,000 tokens as output, and both O1 and Claude support about 200,000 tokens as input. So let's assume that as the standard model. If you assume that, then from a general average standpoint, from our observations, 100 lines of code maps to about 1,000 tokens, right? So there's like a 1:10 ratio between lines and tokens. So that means if you have a 200,000 context window LLM, you can input at a time 2,000 lines of code, right? But here's where we're different. We know that we can support 2,000 lines of code per file if we deploy a single agent to it, but we've split that into multiple agents as well, right? And we stitch the context window. So I would say our theoretical limit, there are, of course, efficiency drops when you stitch context window like that. I would say that our theoretical limit is about 10,000 lines of code per file as an input. I would be very surprised if I saw any repo with any file having 10,000 lines of code. If that's the case, that file A either should not be in the repo or you're doing something very wrong, because I'm pretty sure even your IDEs would struggle with something like that. So the point is, we're not really limited by how much code you can have per file. The second limit that you can think of is how many files there are in the repo, right? So if a repo has 20 million lines of code, it probably has hundreds of thousands of files, right? So that's a pretty big number to grapple with, but we've solved that with a few different ways. One of the easiest ways to solve that is by having folders, subfolders, and structures that govern, and go down to this. to up to about chunks of about 200 files at a time. And that is something that's easily manageable with LLMs of today. And that's more like the ideal case outcome, where you have this repo that's well organized into modules and blocks, and now you can break things up and never run into a module that has more than 200 files.
Yep.
But practically that may not be the case, because if there exist 20 million lines of code repos, they probably haven't been organized, or they are in the process of being organized. So for those cases, we also have a dynamic chunking policy where we look at the limits of our LLM, and if it supports up to 200 files, we'll chunk your repo into 200 files, right? And we'll process the entire repo. We have a very generous compute capacity, both in terms of our infrastructure and the LLM. And as we chunk that, we also graph the repo, and we also embed the code in the repo so that we solidify our understanding of what's in the code, and we can aggregate that over the modules, over the files, over the functions in the files, and over the entire code base, right? So that's how we build an understanding of what the repo contains. And when we need to make changes, we retrieve only the files that are relevant to that change, because you may have 20 million lines of code, but you're probably not going to load all of those files into memory at once, because there's no system in the world that can probably do that, right? Unless you're like working with a supercomputer, right? So more practically, you're probably working on a server. There's this heavy loaded application. You're going to load a bunch of modules at once, which makes sense, but you can segment those files into smaller logical blocks and sequence your changes such that in aggregate, you're able to solve the wider goal. So that's, in a nutshell, how we execute these large-scale refactors.
Yeah, and so practically on a customer basis, if you have 500,000 lines of code, which is still large, you can do it self-serve without us doing any work on our end. You don't have to talk to me. And if you have more than that, if you have 20 million, then you might have to talk to me, and we can configure it to work with that solution. So
yes, because quite often, as is the case, you can't figure out everything from just looking at the code. There's other bits of information. Sometimes these are pieces of documentation. Sometimes it's just context about how the system was built, what it's running on, what is the hardware it needs to support, what are some of the constraints, what's important to the customer. So for those kinds of items, we can only get those from conversation. You can type those in, and we can process most of that. But it always helps to have that additional conversation and get that extra level of detail that we can then help you incorporate into your input to our system and get a better quality result.
So I guess you can always talk to me.
Yes, you should talk to him.
That's
a good idea.
We've seen a lot of excitement, not just in the refactor, but during the refactor, to actually extend the functionality of the platform. And so kind of started off with two unique customer bases. We had folks that were using Blitzy with their product to rapidly develop new features on top of it. And we had this customer set that were refactoring to a more modern code base, maybe using it to go on the cloud. But we've recently seen sort of convergence of these, where we have somebody that says, I both want to refactor this, but also turn this into our own commercial SaaS application, which is really exciting. So talk to me about why we are uniquely positioned to do that together.
Well, if you think about this process holistically, right? So the reason someone wants to refactor is because they probably don't have the tech stack is outdated. They probably don't have the staff to support it. They've accumulated a lot of tech debt, and they aren't able to add new features to it. So it's perfectly logical that you would want to extend your existing source code after you've refactored it, and refactor is probably what's gating you from doing that. So once you've refactored it, you can use the same or similar process to add more features. The difference is, when you refactor, you may or may not want to create a new repo. Right. So when you refactor an existing repo, you may want to split it out into multiple repos, or you may want to go from one technology platform like Python to another, maybe like Java, or vice versa.
Vice versa.
So you can do all of that, but when you're adding a feature, you probably want to just create a pull request and look at that feature before you let that in, right? So you can process both of these flows. The process of how it works in the application is similar. You would connect your repo, install the Blitzy app, input the description of what you want to do, and then the platform takes its time and creates either the new repo or the pull request. And then you can review it and take it forward from there.
I've heard a lot of excitement about this interim step, which really puts the architect in control, which is first the creation of the technical design document of the current status, which is helpful in and of itself.
Yes.
But then the ability, once you go in and you make a sort of refactor request, the redrafting of the technical design document so that you can re-review what's about to be built. And if you want to make changes again, you can make another request and redraft a technical design document. But it's the rapid iteration of getting to the right technical design for the new technology for what the use case is today. Because folks that built the original system sometimes 30, 40 years ago in some instances, right?
Yes.
They don't want a one-to-one map. They have a view of the world that they want to build towards. And so the ability to sort of bring that in and have that checkpoint for the human to sort of have this iterative feedback on what are they about to build here, to see it visually in front of them before they press go is very exciting.
Yes.
Because these systems are so large, right? And they're so hard to sort of wrap your head around. And they're so hard to get organizational buy-in that this is the thing that we are actually going to build.
Right. And I think this is a systemic problem in software development. We always, as humans in the traditional software development process, find us doing one of two things. One is moving forward and pushing new changes. And two is documenting what has been done and creating a system of record for everyone else to follow.
Yeah.
The two are opposed to each other because the incentives are very different. As an engineer, I'm incentivized to deliver more features and get more credit for doing stuff. I'm less incentivized to create documentation, but I'm doing it probably because either it's a compliance measure or it's a measure of reputation and how the team views me as an architect because I have good documentation. And that is typically not a strong enough incentive because the business goals are probably highly aligned with the first one.
Yeah.
So the reason why Blitzy can help you, even if you're not doing a massive refactor, but even doing a day-to-day job in your project, is as commits are pushed to your repos, you can sync your tech spec using the Blitzy platform, and we will create documentation on demand, right? So you now have your engineers can focus on what they like doing and prefer doing. Engineers are never good expressors of thoughts. They're great documenters, but trust me, they don't want to be writing documentation all day.
They want to write Python, not English.
Yes, they want to write Python and they want to do fun stuff rather than, they feel like this is slowing me down, right? I can do so much more.
Yeah.
So you can let AI do all of that
Yeah.
and let the engineers do what they're good at. And at the click of a button, you get the tech spec. The second important thing you mentioned is the system of record, right? As you're building all of this stuff. That is important because you need to, when you're building things, you're telling us you want something and we want to repeat that back to you and make sure that we heard it right? And when I say us and you, I mean the platform UI and your user that's using the platform, right? So when you're putting in a prompt, you're first looking at our understanding of the existing code base, which is an asset to you because it probably doesn't exist if it is super old, right? Because the documentation as a practice is relatively new. We built software for a while and then we realized, man, there should be a way for engineers to quickly ramp up onto this, right? And that's how we invented documentation as a process. But you're doing that automatically. You get that as an asset. You can verify. You can, borrow time from your lead engineer for some time just to review that document and make sure it's all correct. And once you've done that, we maintain that as we add new features. So when you ask us to refactor or when you ask us to add a feature, we maintain the context of the original document and only change what needs to change to achieve your addition and or refactor. And then again, that's again an asset because you're then double checking that we got it right, what you asked us to do. You can still, if it's not accurate, you can still edit it and you can, make sure that it is accurate. And then when you get the code back, it is a higher degree of precision relative to what you expected. And hopefully it's also a higher degree of satisfaction.
So let's talk numbers from a time perspective. You're someone that rebuilt an enterprise application multiple times over in a previous career. And so thinking about Blitzy versus non-Blitzy for a large scale refactor, how much time are we really saving?
Well, that's a great question. So to dig deeper into that, we should probably think about how big the code base is.
Yep.
Let's assume it's about 100,000 lines of code.
Okay.
Right. And you probably have engineers writing about up to maybe 5,000 lines for the lifespan of the project. So you probably have about at least 20 engineers assigned to this. And engineers, on an average, write about
100 lines a day?
100 lines a day. They definitely write more than that. But if you think of it on an average, right? Because these engineers are not just writing code all day. They're communicating.
Yeah.
They're trying to understand the design. They're reviewing code. They're struggling with bugs and issues. And when you aggregate that, that's when 100 lines of code a day makes sense. If you say 100 lines of code to a developer, that will offend them because I definitely write.
I know, but they've done all these studies on like the actual number of engineers that are developers times the number of net new code. And it's like sometimes if all your job is deleting code, that's like some of the most valuable work too. So it's a little bit of a proxy, but yeah, you're spot on.
Right. So with that, if you deploy all 20 engineers at once, and they're all working simultaneously, you could maybe assume that it takes about 2 months with that math. But what happens is that you cannot theoretically just chunk a project into 20 parts and expect everything to be done simultaneously. So more practically, you would probably be doing a fourth of that. Right. So 100,000 lines of code project would be about 8 months. That's roughly how much time you would need to execute with 20 engineers. But with Blitzy, you would get 80% of that at least overnight. Right. So you've saved about 6 months of time there at least. And then you could spend maybe a month or less on the last mile, depending on how complicated the project was. But you've saved 7 months of time, and the code that we produce is well documented as well as a side effect. And also, it's very precise, right? It's also well commented. So with engineers, typically you assume that the code is going to be high quality, but that's not the case. It's very hard to get 20 engineers of the same skill level. It's very hard to get all of them to comment all their code and to follow all the best practices and to be consistent. It's quite common that you will see, if you deploy 20 engineers, you may see up to 5 to 6 different styles, right? Because when you're working with these agencies, it's all a game of scheduling. And it's all a game of resource management, which resources are available to work on the job. And they don't always have the same levels of experience. They haven't even been with the firm for very long. Not everyone has, right? So there's a lot of variability in that is the point. But with Blitzy, you can get consistent code across all of your files, right? And it's all done very, very quickly and at the highest level of quality possible.
So you're taking an 8-month project down to a matter of 4 to 6 weeks in this instance. And McKinsey did a study on what it would take to get a 20,000 line code repo refactored on average in an enterprise. And they said from a sort of human input hours, it was like 700 to 800 hours. So I think your estimate might even be like a best case for the enterprise doing a large refactor. But nevertheless, I think saving 7 months on an 8-month project is pretty compelling. Talk to me about how this problem gets exponentially harder as Codebases scale, both from a code complexity, but also the cost of communication.
I think the cost of communication is something that's very underrated, right? Because you're not just communicating across engineers, you're also communicating across, the stakeholders, right? Because we typically think of it as a top-down system where, you have the stakeholders that have, when I say stakeholders, it could be some old, when I say old, I mean people who built it earlier, right? And have engineers that have context of that repo and have worked on it, right? And then these new engineers that don't have any context. So the old and the new engineers are going to work together to build all of the context that's needed. And there's going to be constant back and forth because you cannot have a single meeting to share context on a 20,000 or 100,000 lines of code repo, right? There's always
too many people in a room too.
There's way too many people in the room. Not everyone is an expert in everything.
There is no documentation.
There is no documentation. So you're going to spend a lot of time in back and forth. In fact, every week you might spend up to 50% of your time just communicating, and that's hard. The other problem is that as you add more engineers, the cost of adding every other engineer is not linear. It is exponential. And it's exponential because it's not just that, it's not always easy to have a clear cut between what parts of a project an engineer can and should work on. There's at any point of time, there's the front end that's dependent on the back end. There's the back end that's deeply integrated with the infrastructure.
Yeah.
There's things like continuous integration and
Yeah.
reviews and all kinds of like builds and all kinds of things that can go wrong, that can make or break things. And there's a separate process for like QA and code quality and reviews and style and all of that. And then there's a separate place for architects where design is important, business goals are important. I haven't even talked about analytics and telemetry at the moment, right? So there are these multiple flywheels that all need to be operating in steady state for the system to work. And it's very hard to get all of them spinning at the same time, right? So every time you add an engineer, you disrupt the system because all of those existing engineers need to communicate with the new engineer, get them ramped up. And by the time they're ramped up, you've already spent a lot of time, you've consumed a lot of time in doing that, right? And then they can start adding value. So the moment you add engineers, it always takes like a month or so, depending on how complex the project is, for them to start contributing at the optimal capacities. You cannot look at it as holistically as adding an engineer piecemeal. You have to look at the whole system, and you have to analyze, what is the cost of what I'm doing. So that is why that's why this is such a challenging problem, right? And that is why the other way to think about it is, where you can ask the question, but what if I have copilots, right? Where I can just give it prompts, I can have it look at the code base. Now, there are a few challenges with that. One, the copilot can never have the context of the whole repo. So if you look at and you talk to, we spoke to a lot of Cursor users, and a lot of Cursor, Copilot, Amazon Q customers are our customers, right? And they're our customers because they realize that Copilots simply cannot comprehend large code bases. They're great for smaller chunks of day-to-day workflows.
Even a couple of files and some of the really great ones.
Yes. If the file is too large, the Copilot is going to struggle. Just because of the math we talked about earlier, right? The most Copilots, if you're on the Pro plan, on the highest paid versions, you have access to the best state-of-the-art models. And even then, if you have more than 2,000 lines of code, it simply cannot fit in the model. And that's a theoretical limit. Don't even get me started on the practical limit, right? It's much less, probably less than 50%. So anything more than 1,000 lines of code, you're not getting optimal results, right? So if you're working on a 1,000,000-line code repo and you're looking at it 1,000 lines of time, oh boy, you're misled. You're not going to have full context. It's going to make mistakes. It's going to make your life harder than it is going to make it easier, right? Because we've seen studies of copilots. They make junior developers up to 60% more productive, but they also slow down the more senior developers. And one of the reasons for that is because senior developers are working on more complicated problems, right? So you could have Copilot, and the Copilot will probably, improve productivity. Let's assume the best case, it works really well. It will increase productivity of how many lines you can write at a time and how fast you can move changes into review. But it's still not going to help you actually get them reviewed and get them moved through the design pipeline. For what you could have misinterpreted the requirements. There is no documentation for the project, so you don't really know what you're working on. And you could always run into issues that Copilots simply cannot solve because you don't know what the original intent of the code was. So the communication cost still exists. And that is why, you cannot throw resources at this and you cannot throw tools at this. You need to have a systemic view like Blitzy does to be able to make a meaningful difference to the problem.
So maybe they could take that 8-month project down to 7 months, or best case 6 months if you were really proficient with copilots. But the path from 8 to 1 is not going to happen. Interesting. And talk to me a little bit more about the most popular modernization use cases that we are seeing right now.
I think some of the most popular ones are changing frameworks. And let's even take a step back. Changing languages. Right. So going from something like Ruby to something like Java, Python. Going from like a .NET native application to a modern one based on maybe the Chromium framework and on C++. Going from, going to a web app based framework, right? Which is what the Chromium framework is. Going from, let's say, so that's some of the language use cases. There are like framework level use cases. In which case the language is the same. So it's still Java, but you're upgrading from an old version of Java to a new one. There are a lot of other framework use cases where, let's say, you have a web app and you're using jQuery, one of the older frameworks, or Bootstrap, and then you want to use React or Vue. So that's an interesting UI refactor use case. There's back-end use cases where you don't have a containerized application and
Yep.
you want a containerized one. You have a monolith, you want to go into microservices or vice versa.
Yeah.
Again, we've seen a lot of those common use cases. There's also some archaic use cases where you have something like PL1
Yeah.
and you want to go all the way to a modern stack.
Yeah.
We can do something like that as well.
Yeah. Interesting. Well, how should folks get started if they want to work with Blitzy on a refactor?
Well, if they want to work with Blitzy, the best way to get started is to talk to us. Go to platform.blitzy.com, create an account, try out the product, book a meeting, talk to us, and we can help you get started.
Awesome.